Okay, on the bench today we have a not often seen. This is a Regency CR-123B. This is a 23 channel AM and sideband CB radio. Customer sent this to me to basically have some restoration work done to it so he can use it. It's a very nice radio. This uses a unit circuit board, so anybody that's familiar with my videos probably knows that I've told you before, most radios weren't made by whoever's name is on the front of the radio. It was probably made by somebody else, and this radio is no exception. So if we look inside, you can see the transformer here is marked unit in. The light's really blinding the camera. There you go. You can see the 7.8 megahertz crystal filter unit in, and then the modulation transformer, which I'll flip the radio up on its side so you can see the bottom when we get done doing a few measurements here. But yep, so it's a good unit in chassis. This uses a now this is an earlier radio, so it does not have an IC for modulation, and for your, not that it matters so much, but for your, the speaker. This used a pair of transistors, push-pull. So these two transistors are your audio or modulation in AM. So basically what happens, your signal comes out of the pre-driver into the audio driver through this transformer into your audio modulation transformers, or the audio amps, and then goes out of those transistors, and then goes through the modulation transformer on the underside of the radio, and then either, depending if you're in receive or transmit, either goes to the speaker, or to the if you're in transmit, goes in to modulate your AM carrier. But so this radio's had all the electrolytic capacitors changed, had a transceiver alignment done. Now some of you may ask, it's a 23 channel radio, what the hell good is that? Well, honestly, people, it can be one of the old tube type, 1, 3, or 5 channel radios. It really doesn't matter. The only thing that dictates what channels they're on are the crystals, and you can always get crystals, because there's just a matter of picking up the phone and ordering, getting custom crystals cut. So now this radio is late enough that it does not use individual receive and transmit crystals. Matter of fact, this is going to be one of the last 23 channel radios, because this radio would be right around 75-year vintage. So what they use is a crystal mixing system. So here's all your crystals down here, and there's what, 6, I think, I'd almost have to look it up. I think it's 6 major crystals that are used with each. As a matter of fact, I just grabbed my crystal mixing chart. I gotta find the radio here. But it's just a matter of changing the crystals. Yeah, so, here's a good example. So you can see, here's the crystal mixing chart for this radio, Regency 123, and you can see which other radios, these basically are the same radios with the same chassis. But these crystals here, you can see they're used in this bank of 4, and then they're used in both AM and sideband. So you could, if you don't use channels, let's say 9, 10, 11, and 12, well, you could pull the 11.905 crystal and then install a higher frequency crystal. So you can see the spacing here, 805, 855, 905, and it just continues in 50 kilohertz steps. So you can see our last crystal here is 12055. So you could just, to get up to channel 40, it's just a matter of, to get your extra channels. So, here's the 12055. You can, whatever channels you want to get, these would be your next steps up to get the next bank of 4 channels. So, like 12105, 12155, 205, or 255. And it's just that simple. And you don't need any tools, because the crystals just plug into sockets. So it's very simple to expand. So if you want to get channel 37, 8, 39, and 40, you could pull the crystal for 4 channels that you don't use, pop that crystal in, and you now have AM and sideband on channel 37, 8, 9, and 40. Another option is a VFO. Back in the day, you could get the Paul VFOs, the Siltronics VFOs. There are lots of different ones available. Advantage if you had one of the Siltronics 90 VFOs, and they made those in several different versions. You'll see a dash and a number on the back of those, and that dictates what radios that VFO was designed to work with, because there's differences, there's different capacitors and different coils used in there. There's 2 different coil size windings, and depending on which VFO you have, sometimes you can rewind those coils to work with your radio, but if it's the wrong format coil form, then yeah, you just completely got the wrong VFO. But in any case, you can get a Siltronics VFO 90. The advantage of those is they have the lower left-hand switch on those is a crystal switch. So you'll see it has VFO and then 3 crystal positions. Well, what that's designed to do is, when you take your crystal out of your radio here, you could put this crystal into the Siltronics VFO, run your coax cable from the the VFO output in here. What I usually would do is to make it so you don't need to actually modify the radio any, no soldering required basically inside the radio, is I take an old crystal, I've got thousands of them, I just cut the top off of the can, and I'll plumb that coax cable into the crystal socket, into that old crystal housing. Okay, and then I can just plug my coax cable into the original crystal socket. But then you can use the VFO. Like I say, the advantage of a crystal is you turn the knob, on the front of your radio, bam, you're on frequency. You don't have to sit there and fiddle with the VFO tuning knob. So you can, like I say, take the crystal out, move that in there. Now, if you wanted to have good crystal stability, frequency stability on channel 37, 8, 39, and 40, let's say, you could get that crystal like I had showed, which would be, 12.555, I think it was. I'd pull my chart back out. But if you were to get that crystal cut and stick that in the Siltronics VFO in, let's say, crystal socket number 2, then when you flip that switch to selector number 2, you would have crystal controlled 37, 38, 39, and 40. So like I say, there's advantages to the Siltronics 90s. I think they're a little bit more stable once they warm up, because they do generate some heat, and like anything, it's like one of these. That's the only, if there is a downfall to this type of radio, it's frequency stability. Now, once they warm up, they're very stable. It's like any crystal controlled radio. People that are familiar with the modern day radios, actually, it's really no difference. These modern radios, my God, they drift so horribly. That's just because of poor design that they use. But your older crystal controller, because there's a lot of crystals down here, okay, and you can see every single one has a trimmer capacitor beside it for when you do the alignment. So there's lots of adjustments in there. It takes it takes a lot more time to do an alignment on one of these than it does a modern radio, just because there's so many more adjustments in here. The worst being the Tram D201A 40 channel. Yes, that thing, they pretty much cornered the market on crystal when they made those things. But, so, in any case, there's a quick view of the inside. Now, this had some work done to it. I'm really not sure what was done, honestly. The only modification I saw that had been done to this was, I believe, was the modulation limiter was clipped, and the modulation meter did not work. And that was because someone had cut another diode. They had cut too many diodes, apparently, when they did the modulation limiter. They cut out the AMC limiter. So that's all been re-enabled. I replaced those diodes. There's the old ones there. And then, like I say, all the electrolytic capacitors were replaced. Yes, this has a shitload of them. Because, man, they're really densely packed down here in some spots. But, some of the big main caps were upgraded in value from, their original. Actually, there's several of them in here were upgraded in value. But one thing I did notice was, and it's something I see all the time, and I've done a separate video on it. And I knew when I came to doing the alignment that I'd have a horrible 54 megahertz spur, and of course I did, because and I didn't touch it. You can see all the rest of the coils have been resealed with wax, except for that one, and that's because I want to show it in the video. Yes, someone has adjusted the 54 megahertz trap circuit coil in apparent attempt to get more power out of their radio, not realizing that all of the power that they got when they turned that core right there was in the 54 megahertz band. So great if you want to try to talk to somebody over their television, not so great if you're trying to actually talk to somebody on a CB radio. So the first thing I want to show is excuse me, is the carrier suppression on this. This has very good carrier suppression. So I have it hooked up right now to the spectrum analyzer, which we'll be needing that for the when we do the, I'll show you the trap circuit adjustment. So here's an AM. And what did I have? Oh, hold on a second there. Yeah, I guess that can help. Huh. That's weird. I'm just sitting here playing with it. I had apparently had the channel selector in between channels. That was weird. Oh, in any case. So, back to the video. Now I figured out what the hell was going on, because I keyed the mic and I had full modulated power. The needle was swung to the right. And apparently I had it stuck in between channels there. So, in any case. So there is our AM carrier. Okay, I have this is the center frequency, 27115. I have the span set to only 5 kilohertz. You can see down here, 5 kilohertz. Resolution, video bandwidth are both at 100 hertz. Now I'm going to switch over to sideband. So I'm in upper sideband. So you can see the carrier has almost completely been removed. So let's put a marker on there, and we'll do a delta marker, and then switch to sideband. So we have 69 to 70, it's fluctuating right around 69 to 70 dB carrier suppression. So very, very good carrier suppression. So that's definitely what you do want to see. So now let's change this to, well, actually, let's see here. First thing, we can get rid of the marker. Frequency 54. Oh no, actually I want to start at 54. Stop 55. And switch back to AM. And there's our spike. Go to peak. Center of the peak. We'll make our span 20. See, is it still on the screen? Yes, it is. And now do span. Peak. Okay, so that's what I saw. So now what I'm going to do, and what I'm going to adjust is, get around here so maybe I can get the analyzer, and you can just see the coil down here. So that's what I'm going to be adjusting. And this is the one that no one should ever adjust unless they do have a spectrum analyzer. Oh, there it goes. I think that's about as good as we're going to get it. So, and that's at negative 34 dBm. So, very good suppression on 54 megahertz second harmonic. So now it's properly adjusted. Now I got to do seal that core properly. Like I say, I just wanted to show again why that shouldn't ever be adjusted. So I've got the power turned off to the radio. And let me get it flipped up here so you can see the underside. Now I'm not 100% done with this. I do still need to bundle the wires back up. You can see a bunch of the wires are unbundled. This is a bit of a nightmare to do electrolytic capacitor change on, because most of your capacitors, unfortunately, all fall underneath of these wiring harnesses. It's a bit of a pain in the butt trying to get to them, and there are a lot of them. But in any case, so here you can see here's your audio output transformer, or the modulation transformer. Fairly straightforward, not a lot to see other than a shitload of wire on the underside. Now, one thing, if you're not familiar with old radios, you may have or may not have noticed already is, what do we have in here? There's a big variable capacitor. Well, that is your clarifier. Okay, now these radios, the clarifier is, I guess today you would call it unlocked. This radio was produced back when you bought a CB radio. Your transmit and receive frequency were both changed when you turned the clarifier. Unlike radios nowadays, they fall into the newer FCC regulations. The transmit frequency is locked. So when you turn the clarifier on a modern CB radio, you're adjusting something like this, a potentiometer. You're not adjusting a variable capacitor. They use a variable resistor because they have it's not complicated, but it has a completely separate circuit where there really is no clarifier circuit in this radio. That capacitor, simply, if you look at it, it's just a coax cable. It goes down to the crystal synthesizer section, and that's all it does. Matter of fact, if I grab the schematic, I can show you how simple the clarifier circuit is, and most early CB radios were like this. Let's see here, and here we go. So the clarifier, that's it right there. That's all there is to it. Okay, and you can see that just adds into and adjusts the frequency of these crystals here. So depending which crystal you have selected in using the channel selector, it's just, that capacitor is just added into the circuit. Where nowadays having selectable, or having a locked transmit frequency, they have a switching system, so your receive frequency is tuned by the clarifier, yet your transmit frequency is only adjustable by somebody like me on the inside of the radio when you do the transceiver alignment. So yes, the older radios, the clarifier circuit was so much simpler, just a variable capacitor. Now, it cost a lot more. I mean, you look at how, you price how much a variable trimmer cap or a variable air core capacitor like that costs nowadays. Yeah, they're really expensive by today's standards. But built with quality. It's a good ceramic adjustable cap. So if you're not familiar, like I say, I just thought I'd point that out. So there you go. There's the underside. Like I say, the only thing I really have left to do to this is I got to have to seal the core for that 54 megahertz trap coil, bundle up some of the wires here, and this thing will be ready to head back to the customer. Now I had changed the lights to LEDs. Actually, I don't think you saw that on camera. Let me get hooked up here. My AC power supply back on. Oh, and I had also another thing that had been done to this. If you watched the video, probably the video previous to this one, I'd showed how to reapply these aluminum trim plates on these radios. So yeah, the one thing, the reason I ran into why that was a problem was I changed the mic jack out. So in any case, actually what I want to show you is on the front of the radio. So AC's turned on. So bright LED. Now, actually, they look blindingly bright in the camera. They're not. They're not that ungodly bright. You can read the digits very easily. But this came from the factory with a transmit. If you notice, there's no LED lights around here for receive transmit switching. But it does have a transmit light, and that transmit light was just a, matter of fact, I can reach in my little benchtop trash can here and grab it, was this red light bulb. So anytime you key the transmitter, the red light bulb would light. So that's also been changed over to, you can see, a red LED. So there you go. The Regency CR-123B AM sideband 23 channel radio.